more creative data visualization in Learn D3, and also doing data visualization in Illustrator, and to a lesser degree also with R and Ggplot. And I happen to have given my first training about D3 just yesterday, so I would be very happy to share what I shared with my participants in the workshop yesterday with any people interested here in the topic. We also asked about who would like to give these trainings, and as you can see for V3 we have like a blank there, and so I would like to try to fill that gap that we have. What I did was I created a little Google form where you can go to and indicate whether or not you have interest in following the training on either D3 or on Ggplot or on training about non-standard visualizations. So training about going beyond just bars and lines. And in the Google form there is also an option to indicate that you are interested in giving a training on another subject or another topic, or maybe you would like to give these trainings on D3 or Ggplot. So if you go there, you can indicate if you're interested, and I think if we find like 10 or 12 or 15 people interested in following a course on these topics, then I think we can organize a day where we hire a location, where we organize some catering, and then we can organize trainings within the framework of data vis. So I would love to organize these trainings. Another thing that I mentioned also in my opening keynote in the first meetup was I'd like to go on a hunt for historical Belgian data visualization, because I'm sure that in the archives of the National Library, and maybe also in other archives, we can find some nice examples of historical data visualizations. The only thing is that someone needs to organize the hunt for these visualizations, and I think there is no one. Request at the National Library, the Royal Library, to see these things in real life and actually visit the library and getting these things on our hands. So I'm aiming to organize this somewhere in December or January, because it needs to be researched first. If you can just go to the library and then only start looking there, you have to do some preparations and request to get these pieces out of the archive into the reading room. So we need to organize this a little bit. And I would like to do this through the meet that we have. So I'll probably send an invite to all the Meetup users of the group to find people who are interested in participating in this hunt for historical Belgian data. Then before we jump to the speakers, we also need to discuss our next meetup. There is no date set yet, there is no location set yet, but we got a little proposal, and I'm going to give the word here to my co-organizer Stan, who's going to explain what that invitation was, and then also, yeah, maybe we can already decide what we're going to do with that invitation.
Thank you, Michael. It's actually not such a big deal to take the mic for that. But anyway, we got an offer from the Port of Antwerp to have our meeting in their main office in Antwerp. I don't know if you know it, we don't have a picture, but it's a very impressive building in a really nice location. Now, it's not in Brussels, it's in Antwerp, but the connectivity with public transport is okay-ish. So it's better than last time. For those that were in Mechelen last time, connectivity is much better. So, can I see hands of who is interested to go to Antwerp and the port of Antwerp and see? Okay. So I would say the majority, you know, a slight majority is willing to go. Okay, so we take it into consideration, and if public transport would be a problem, maybe we can arrange some. All right, that was it. Thank you for that.
Thank you. With further ado, I would like to introduce the next speaker, which is Ted Wood. He will be speaking about his population pyramid project and also about atlases and education. I'm very curious about what he has to say. So, yeah, applause. Good one.
Keynote. Okay. Hello. So first, just a few words about me. Who am I? My name is Martin de Ville. I used to be a computer science researcher like 10 years ago at the University of Brussels, the French-speaking one. Currently, I'm a software engineer, I would say, so I use all these technologies. I put D3 to say, okay, that's what I used to do. Database actually, but I do a lot of GS outside of that in my daily work. I worked in several startups over 10 years, so all kind of fields. And I'm going to tell a little bit of story about it. So, first, Odimo. Okay. This is the site. So the site is just displaying population pyramids for the whole world from 1950 to 2000 onward. Okay. It's based on the data from the United Nations, the World Population Prospects. And it's, so for the demo, that's basically it. So I'm going to show that I have a few other things on the side. But the site also allows you to compare between the countries. So for example, in Afghanistan, people are not living very old. I'm assuming that everybody understands this kind of graph. Is it a good assumption? Yeah? Okay. So I'm not going to explain much what it is. So the interesting part is just the dynamic part of the site. And I did for those graphs, and it was quite successful in a sense. So at some point I thought, okay, I'm going to do more stuff like this, and I did basic stuff. This is a basic graph from degree, for example, just available out of the box, but that allows you to compare the size of the population of every country in the world. And you have color per continent, for example. And something that's important to me is that I try to have some animation because it provides a small wow effect. Okay, so this is the site. So now a bit of story about it. Just touch. It went, okay. No? Okay, it's coming back. So, the site, I would say, is kind of boring. I mean, it's a subject, it was something that I was told in school when I was small, the population parameters, the whole thing. But at the same time, this is something that didn't exist. So it's really a data set that everybody knows exists, has seen somewhere. But I just made it available online, and apparently people are finding that useful. Some more information about the site. It supports 10 languages, which is kind of easy for this kind of stuff because I don't have much text actually. So translating it cost me like $40. In 10 languages, so that was easy. It's very light, so every page, most page loads in one request actually, so it's very, very fast, and it works on mobile, and it's actually a nice for SEO. So it's thought to be widely available and easy to use and fast. So a bit of story. How did I end up doing that? In 2011, I was interested by open data at that point. That was the thing at the time that people were talking a lot about. And I thought, okay, I would like to do something. And it turned out that there was a weekend where my wife, she's a doctor, and she told me, okay, I have to work this weekend, so you stop at home with the kids. Well, okay. So I intended to go to a startup weekend, so I was a bit frustrated. So I decided to start something at that point, and I was thinking about this open data, and I thought about this first exposition I ever had to dataviz. I think it's this atlas, actually, that I still have from secondary school, which included those population parameters that you can see, for example, for the Netherlands there. So I said, okay, I'm going to take a look. Yeah, the data is there. There was a library that I found called I was very happy. I was on the front page of Academics, and I had done some open data, and people liked it on Twitter. So yeah, that was the only point of all this. And I didn't touch it and didn't watch the analytics for maybe 1 year and a half. And at some point I came back and you can see the small spikes in the middle. I was okay, there are 300, 400 people using the site still. Okay, so apparently somebody is interested. So I thought, okay, maybe I should optimize it a little bit, do some SEO, and create a new version, which I did almost 2 years later, and there's a big spike you can see there. I posted it again on Academics, and this time it went to the top. I was super happy. I was famous in Academics point. And yeah, that's the story basically. I started it, people got interested by the subject and thought it was useful. I decided to improve it, and it began to grow. But it began to grow quite a lot actually. Because you have the same graph at the top, and actually it's just the beginning of what you see at the bottom. So since then there have been like 13 million people that have used the site, so average 5 to 6 minutes of time. So apparently people are really. And so it went on like a news, and it gets famous in some sense, because at some point on Rosling, which I was a big fan of, tweeted it, so wow, again, no point. He even presented it to banking in meetings, that was fun. So sorry, I'm boasting a little bit, but it's the first time I can speak publicly about this. So sorry. It was used on the World Economic Forum site, and last year also, 2 years ago, it went, I did some GIF, if you wish, videos, let's say, and they went on the front page of Reddit, and so they were shared by lots and lots of people. So, okay, so this is kind of way more success than I expected at the beginning, and I was not really going for it. It just happened. But it took time, so as you can see, it's because it's not my job. I couldn't live out of that, but I feel it. What about the tech? So for those interested, so it's D3 now. So when I redid the new version, I use D3. The backend is in Python, Django, using Postgres. There is only one machine running on a small VPS, so it cost me like from €40 a month. And when I was on my bicycle coming, I thought, oh well, I should mention there is a lot of caching because I have a ton of requests every day, and the main source of requests are the search engines that are really driving like. Sometimes Baidu can send you millions of requests a day. You don't know why, but they decide to do it. Because your site is in Chinese. That's that. Okay. So that's about the text. So it's quite lightweight in the end. So now, when you do a website like this, you don't really know who are the users. You put it on the internet, and you hope that somebody will be interested. Over my years, I still get some insights about who's using the site, and the first source of traffic is people Googling something like population of China in 1950 or something like this, and they end up on the site because it's quite well SEO optimized. For this, okay, that's nice, but what really is important to me is that actually there are lots of educators and students that are using the site. So if you stalk a little bit on Twitter, for example, you can find people that are tweeting pictures like this saying, okay, today we had our exercise with the populationparent.net with the kids, and they liked it, and so you can have some insight when people are asking, can I use your image in my homework and stuff like this. And so you get that feeling, okay, actually it's used a lot in education. And the other thing that was a hint is the image at the bottom. So when you look at the analytics on Google, you see that people are connecting by groups of 30. And what is a group of 30? It's a class. And it took me a long time to figure that thing out. Okay, but why does that happen? And so I'm very happy because that was actually exactly what I wanted when I did the site at first. And a lot of research, either in public or private institutions, are using it for their reports. And for example, I used to do research. I have a few publications and so on. But this thing dwarfs everything else because it's been cited in like 700 articles or something like this. It's kind of silly comparing what I did before and this small thing I started in the beginning. Okay, so that's for the story. And so when Martin asked me what do you want to talk about, or what's the title of your presentation, I say, oh, maybe there's something to say about the fact that this whole thing to me proves that there is a need to replace those groups that you had in school. Because there are a lot of things that makes me think that. First, I only did a few graphs, all in all, I think there are 5 to 6 different graphs on the site. A lot of data points and very dynamic and so on, so lots of different pages, but very few things. And with that, I got that number of users. So, and frankly, I did not do so much promotion. So there is obviously a need for this kind of boring but useful data. That's my view of it, at least. From my exposition to schools, I have kids that are in schools and so on. Those books, they've become worse. They're less good than they used to be. They're worse than what they used to be. They're worse than what they used to be. They're very expensive for schools, so when you have to buy 30 of this, it's expensive. And schools don't have money, not here and not in any country. Basically, in the US, it's the same. In Switzerland, it's not the case, but you can really see that the site is used everywhere through the world. Actually, I could show you a map if you wish. But my feeling is that, okay, and people like this kind of, I should put my point. and the book publishers are doing a really bad job at digital. So the people who did this, basically, they still do this, but in PDF. So that's the digital version of this. And obviously, there is a possibility to do way more than that with all these data visualization tools that we know now. Those books are expensive. You have to buy license to use them. So for class, you need the 30 license of the book and so on. So really, the book publishing is living in the past for that. The fact that you can have interactivity helps students integrate the knowledge and works very well for their homework. So I see a lot of homework on this. And my opinion is that nothing digital that I know beats this. It's beautiful, this thing. Actually, you take a look, and I have kind of fond memories of it. But when I opened it, I was, okay, but this is actually better than what I see on the internet every day. For example, just a remark for me, I rarely see good contour maps on the web. Those are the maps that you see on the web, where you can see isotherm. I don't know if it's supposed to say that in English, but temperature zones, depending on the summer at the bottom and winter at the top. And this is really beautiful, and this is something that is hard to do using web text. So it's not easy. I don't know exactly how I would tackle that problem right now. And so, what I wanted to say is just, okay, maybe there is something to do here, and obviously there seems to be interest. So that's kind of my message to you. Is, okay, maybe there is something to try. I don't have all the time to do it, so and there are lots of skilled people, so if you want, take the idea and run. Yeah, that's it. And so just to finish, a few random database stuff about all this after 9 years tweaking this site. The animations you put on a site like this, they might be silly. People criticize it doesn't mean anything and so on. But definitely that's what when you click and start to move, that's when people start to react to what you're showing. When you compare Belgium to Afghanistan, that's why you got their attention. So I tend to like them, even if they are not meaningful, or you could say it's not a good idea to have them. Something I really think is a problem usually with lots of databases that I'm looking at is actually your database interest is strictly limited by the underlying data. So if the data is not very good or does not relate to people you are talking to, okay, it might be shiny and beautiful, but it won't interest so much. It's too bad that this is not. The site is actually funded by ads, which I don't like. But on the other hand, there is no good reason for me to just let that run. I have kids, so I put ad, and frankly, when I put them the first day, I was okay. Somebody is going to be super angry and mad at me. How do you dare using those open data? ads. But actually, that never happened. So they are not very intrusive. You're not talking Android games or levels of apps. But okay, so that's an information to you. So I already told you, but I really think that search engine optimization is important, and that's what allows the site to reach such an audience. And so internationalizing your site, it works. So lots of users in China, Japan, and so on. So that's fun. And something that feeling about all this is that if I had built this on top of a platform like Tableau or whatever, it wouldn't have lived so, because the cost would have become too expensive. So I'm quite happy. I just did it on my small laptop and put it on a small machine somewhere. And you can go very big, apparently, with very small resources. So, and I think that's it. Yeah.
Thank you, Martin. Very interesting. Also, yeah, with a nice message in the end. So lots of work to do to put atlases online, and it doesn't have to be like very big and very super well designed to be effective. So thank you very much. Our next speaker. Yeah, do we have time for questions? We're already running a little bit late, so if you have questions, you can grab Martin during the break or after the talks. Okay, our next speaker is Frederik de Blazer. I think it's better that he introduces himself properly, because I'm not sure at what lab or at what university he's even working, but he's a researcher is working at the crossing of arts and data, and of course their visualization comes to mind, and he's also the author of Notebox, which is a visualization tool. So we asked him to introduce Notebox, which is, as first slide is already saying, a data visualization tool made in Belgium. So yeah, Frederik, take it away.
Yeah, thank you. Hi. So I'm Frederik. Will explain a little bit of my context, just a little bit, which is that I work here in St. Lucas in Antwerp, which is an art school, art college. And it's really an art college. We do painting, sculpting, photography, graphic design, advertising, illustration, all that kind of thing. But there's also, because it's an academic institution, we also have a research component, and that research component is where I work in. I'm part of a group that's called eMerge, and we develop notebooks, which, if I'm lucky, will show up in a minute. Yes, beautiful. We're tempting the demo gods a little bit today, but that's fine. We've been working on this for a bit, and so I will quickly show you a little bit of where it comes from and where we're going. So Notebox 1, actually when we started, it's basically based on this idea of software like this. Who knows what this is? Anybody seen it? No? History. This is designed by numbers by John Mena. Everybody knows John Mena? No? So, famous designer, and he designed this program which was basically made for generative design. So basically you type these really small programs, just in squares of 100 by 100, and then these programs do things. So it's a very imperative way of programming. Who knows what this is? Processing, yes. This is processing by P.C. Rees and then Fry. And it's around that same time that we developed Notebox. So this is Notebox 1, the first version. And as you can see, it's very similar to the way that processing works. It's built off another program that's called Drawbot, which is also still active by guys in Letter. And what we have is here on the one side we have visuals, we have the code, and then at the bottom there's errors most of the time. So But the program is very straightforward, right? So you type in the command, and then the command gets printed. It does what that command does, right? So I have a small animation of this, where you can see what it's basically doing. And this is called a painter's model, which you're familiar with. If you're working with Canvas, for example, it's based on the same idea, or OpenGL or whatever. So it's basically, you do a step, it sets some state, it says, okay, the fill color is now this, and then it draws something, and the next thing draws on top of it. Right? I'm not giving you a full tutorial, but that's basically how Notebox 1 works. And it works very well. The only problem is that this state requires some knowledge in your head that you have to keep in your head. Well, what's the state at this point in my program? It also messes up copy and pasting. If you copy and paste a part of this program and you forgot to fill line, then it doesn't work anymore. So there's some subtleties that make it not work as well. But there are some really cool examples. So this, we do a lot of workshops with these software applications. And so this is the work of a student. And what she did, none of these students are programmers, but basically what they do is they take basic shapes that they might do in Illustrator or somewhere else, they draw them and then they take them into the program and they start messing about. So these are not data visualizations, these are generative designs. So the data is basically randomized. Right? A really nice one that I like is, as I said, not all of the programs have input, but in this case this one has. It has, this is the evil font. It's a font, it's a generative font, and has one specific parameter which is called evilness, which you can control. So this is at 0 evil, and then we can add a little bit of evil, and then do some more evil, even more evil, 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 evil. So it's really fun to do with people. Also, what I really like about it is these are not sliders that you'll find in traditional applications like Illustrator or whatever. You can basically use Notebooks to make your own sliders, to invent your own parameters and then control them. This is something that we know as data visualizers, but it's still really cool to talk to that with students. Another interesting project from a while ago is from Spamghetto. It's from an Italian design bureau called Todo. And what they did is they took all the spam that they found and they made wallpaper out of it. So you can actually send them your spam folder, and they will run the Notebooks program, and then they will generate your spam. So here I had from the desk of the president of Trump University, so it's still pretty active. So really cool. Now, what we found is that a couple of these issues that I mentioned are actually quite big issues, and the biggest one I think is programming. Because a lot of the people that we teach are graphic designers or illustrators. They don't have a background in programming and they're not really interested in programming, or they see it as too big of a hurdle. Now we've tried teaching in programming and that works for some people, it doesn't work for everybody. So we started thinking, okay, can we change this model around? Can we do something else? And that's where we came up with the idea of Notebooks 3. And Notebooks 3 is a visual application. This is actually a later version, but I'll talk about that in a minute. And it doesn't require any programming, it's basically built out of these small building blocks that you build up together. And all of these small steps do a part of that visualization. I'll explain. So you can think of it as a factory, right? So you have cars that run from the factory, or not. Yeah. And then every machine or every station in the factory basically does a part of that. Right? Now we're not a car factory, we're doing data visualization, so we go somewhere from the data to the visuals. Okay? And we have some intermediate steps, of course, that we have to take. We have to do some data processing to get it in a correct shape. And then at some point, of course, we have to turn a piece of data into a visual component, into a visual parameter. That could be a width to create a bar chart, or it could be changing the size of the circle, the radius, or it could be something else, changing elements on the page, putting them on a map, doing numerical projection, things like that. So we split that up into discrete steps. Here's an example. These are all nodes that are in Notebooks. A super simple example. We import data from CSV. We do some lookup nodes to extract out the parts that we need. And then we need to do a conversion. Most of the time the data is not exactly the way that we want it, so we need to convert it. We change the range, for example. If it's like in the millions, we change it to pixel data that we can use. Or we use just simple multiplying. And then we convert that to visual shapes, so either text, rectangles, lines, we have all these shapes that we can use. You can also draw your own if you want. And then we can modify them, we can tweak them, we can refine them a little bit, and then we combine everything with this merchant, we combine everything into one thing. So the entire software basically uses this completely consistent system that's really easy to learn. Even if you don't really understand the process, you can still take an existing notebook script and start tweaking the parameters. So don't change the architecture of the thing at all, just start tweaking the parameters. So all of these visualizations or generative designs are all based with the same parameters, right? I didn't change any units. The whole thing got a bit complex of the course of development, but basically we made several versions. Notebooks 2 works significantly different, we don't support that anymore. But Notebooks 3 and Notebooks Live all use the same model of evaluation. The difference is that Notebooks Live runs on the web, and Notebooks 3 is an open source application that runs on the desktop. So I'll present some examples. This is an example from Jan Albrecht that we did in data visualization workshop in The Hague about the shipwrecks of California. So all the ships that crashed before the coast of California. And he basically made that into a timeline where you can also see the tonnage, so the size of each ship, basically. And what's interesting is that in the beginning there's lots of crashes, then there's a lot of maritime transport, so there's lots of stuff. And in the end you see the safety has improved a lot, so there's not many crashes, or not even at all. But if there's a crash, it's a really big one, because the sizes of the ships are much bigger. This is a visualization of the stockfish in the North Sea, and as you can see, it's quite dramatic. Beautiful. See? It proves my point. It's so dramatic that it crashes, so you see that it sort of goes down all the way. And I think the one that's super dramatic, that's like 2 now. Yeah, so that's like all the way down. Not good. This is one of my favorites, also made by students, because it sort of brings everything together. They did a lot of data prep beforehand. Not all of that can be done in notebooks. So their visualization was about taking 50 years of film speech. So basically they took the subtitle data of films for the last 50 years, of 50 most popular films for each year. Out of that they took the 50 most popular words, and from those they made these sound waves that basically represent how frequent that word is used over time. So I took all that data in initially. If you just plot that in Excel, you get something like this, right? This is a bit egging on Excel, but that's if you put everything on top of each other. Of course, you would do it a different way. You would do it with small multiples like here. And what's cool is that they could use notebooks to basically build out their own custom visualization. In this case, this sound shape, right? Because it makes sense, it's about speech. And this is a custom node, again, like the evil thing that I showed before. You can make your own custom node that's basically packaged up inside with different nodes that you can combine. And then you can make your own shape, attach data to that thing, and then out comes the visual thing. Right? So it's basically neatly packaged. And so here's a close-up of all these words that you can see progressing over time. Another really nice one that I really like is the work of Nicolas Rougeau, his work was, or this work is called Off the Stack, and he's basically doing visualizations of musical pieces, but he's using notebooks to do it, amongst other tools. And it's interesting because he's also blogging about his process on how he used the tool there. So it's not just students using it. So here are a couple of the different visualizations for these different musical pieces. And there's a really interesting blog post that he wrote about making this process, explaining all the different steps going through it. So basically, really shortly, first taking the data into a musical program, getting that from MIDI to another format like XML, then doing this typical data conversion that we all love. Then, of course, at some point, Google Sheets has to be involved, otherwise it's not a data visualization. And then he took that into notebooks, and then you can see it here. What's really nice is that he labeled all these different bits. So basically, you can think of the network. So this is the network. It's basically the visualization that I showed before. It all starts with this import thing, and then there's like a couple of nodes. There are these bluish ones that are about processing the data, taking that into different shapes. Different data ranges, converting them, things like that.
And then number 10, as you can see here, once they start becoming black, those are actually visual nodes, right? So at that point, you do the conversion from something that's purely data, numbers, to something that's actually visual. And you see, you can't see it really well, but for example, this rect thing has 4 input ports. So there's one for X, one for Y, one for width, and one for height. And you connect, depending on where you connect it to, it does something else. So you should check out his blog, it's awesome, his work. I really love what he's doing there with it. I sort of go over this very shortly, like, okay, what's the, it's connecting all of these things, but of course, all of the things we saw was not just one data point, right? It's always multiple data points. So where does all this data come from? Where are the loops, basically? And you can think of notebooks a bit as a functional programming language, which means there's no explicit loops. Instead, notebooks just loops over everything implicitly. It does that automatically. And the system that we use is called list matching. And basically what we do, I try to explain visually, is if you have 2 inputs, and then it's trying to match. So these dots might be positions, for example, these might be data elements, and so it's placing every element on a dot, every number on a dot, right? So 0 goes first, 1 goes first, so it's matching basically, taking these 2 things and putting them together. If the lists don't match, then notebooks does something else. So if you just have 1 element and you have lots of dots, then it's just repeating it, right? And if you have 2 elements, or any other combination, it's basically flipping between these 2. So it's iterating over this thing. It's taking the longest list and basically iterating over the shortest one. So that's how list matching works. And that works really well, actually. It works really, sort of gives a good overview of what everything is doing. Another thing that notebooks is really useful for, and that we really, really love for working with students, and that we actually teach students, is visual debugging. Because every step does something very concrete, we can always check if something's going wrong or not. And I'll show you, again, I'm attempting the demo routes, but I'm here. Let's see if I can find my notebooks file. And some idiot made a mistake in this notebooks file. This is actually something we do with students as well. So as they're learning notebooks, we basically say, okay, now switch computers with your friend next to you and break the network. So do something that makes it fail. There we go. I'm trying to do it from a distance, so extra hard challenge because I don't see anything. So this is my visual view. And what I want here is, I was expecting these lines in the middle, but I don't see anything, so what's going on? So the thing it's rendering is the thing here at the bottom, this combine node is basically merging everything together. And I see that something's wrong, right? So I can go up the stack, I can find, okay, translate. This looks okay, these are these pieces of text, that still works. But this other part here, this colorized thing and this thing, doesn't really work. So what we can do in notebooks is basically go click up, 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 until we can find something that's failing, where we don't expect the data to see. For example, this lookup shows the frequency of every word that we see. We're visualizing the number of words in all Metallica albums. Just to show you. And here I have a problem, because here it says album, but I would expect a list of albums from Metallica, but I don't see anything because I made a mistake here. So I can fix it. Now I see all the data, and now I can sort of go back, down, down, down. Look at all the lines, this looks good. I colorize them, I combine them, and now I can see everything. So this is really helpful, right? Because there's no loop, there's no imperative thing where it sort of messes up somewhere in between and we don't know where it is. We can always just go up each step and sort of see, okay, what's the expectation? What do we expect to get out of that? And then we can actually see visually the data. Right? Does that make sense? So, notebooks. As I talked about before, this works all really well, but one thing that we're missing was the web. We couldn't do anything interactive. So we made a version, I think 2 years ago now, called Notebooks Live. That's basically taking all of this stuff and putting that on the web. And here's a very small, very small demo that I was going to show, but it's, there it is. So it's basically building a dashboard application from a list of Twitter tweets. So now it's importing these tweets, but you can imagine that this is a real-time data stream, which we also support. So we make a scale, we say, okay, this is the minimum and maximum date. We do a conversion, and this makes it into pixels. We then take these pixels and convert them into points. Depending on where we connect them, we can see this in X and or Y value. And then we can do things like sentiment analysis, for example, on it. So here we use a different library for that. You can see it's really small, the sentiment analysis, so we can add a multiply node to extract that and make positive and negative sentiments. We can turn this into ellipses, we can give them a color, so we can tweak them, as you can see here. And then we can add a legend if we want. We can give that a color. And then we have these two things, so we combine everything together, and that's our visualization, basically. So now what we can do is we can say, oh, we have a dashboard application or whatever, so we're going to tweak this so it fits in the dashboard application, make everything get smaller. We have a little piece of iframe code that we can copy and paste in a dashboard, and you can see that the thing is appearing there. It's a bit too big, so we can sort of still tweak it, it's still live. So we can tweak that thing, put that in, and now you can see it works. Because it's a procedure, we can change it. We can say, well, we want to do it for other, these are telecom operators, so we can want to do it with other datasets from other telecom operators. And all the other visualizations that you see on the dashboards are also made into notebooks. So this is word cloud, for example. So you can see all of these are also in the app. So it works really well for doing that kind of thing. Now, the appeal of notebooks is that we have this full breadth of the web. We can use everything in the web, including interactivity. So I'm sort of mixing these traditional database applications with a bit less serious work that I like to do with my students as well. So one student was fascinated with the speed, or let's say lack thereof, of revolving doors in shopping centers. So if you go through the revolving door, it's super slow. You have to wait. So he's thinking, can I make an interactive application that shows that in Notebook? So we made that. So this is all the people coming in, and then you can change the motor speed. You can say how fast people are going, how eager they are, if it's like shopping season or just normal season. And then of course you can sort of tweak the motor speed and make everything go crazy. Yeah. Cool. For a more serious thing maybe, we were thinking about different models because, as I said, I'm working in an academic context. We have to think a little bit about, okay, can we make this into a commercial application? So we talked to people from the standard. They're actually here. Hi. So you can talk to them. They're awesome. And we worked with them on this project called Gemeente Profile, or Profiles of Cities, which was this big data set that they gave out. And basically what we did is we prepared everything, so we had like a couple of days only to do the visualization. So we know sort of the format, but we didn't know the actual data, so we had to sort of make sure that everything was ready. And once they released the report, we're like, oh no, maybe it's super beautiful, and we will be out of a job because they have this beautiful visualization. But this is what came out of the report, so we didn't have to worry too much. And it was like 150 pages of this for every city. So what we did is we basically made a day in the life of somebody who lives in Erichem, for example, or Ghana. And as you can see, it sort of changes the background as well. So we had an illustrator working on that as well, for the preview, for example. And these are all, to have all these different variations for all the different cities that we could do. And basically we integrated, because it's sort of integrated, it generates everything. It generates the HTML code, it generates the text, it has, Notebooks has nodes for changing the text as well, so if you want to do templating like things, you can do that as well. So it would do like a day in editing, for example, in this case. And you and 20,000, whatever, inhabitants. And then you have things like these visualizations where it sort of changes the number of cars depending on how busy it is in your specific city. Or you have these people of foreign origin would be listed here, and that would change depending on how many you have. And this is how you would do that in Notebook. So every small segment is basically this Notebooks thing, and sort of groups everything together. It was a really fun project to do because we could have this combination of people from illustration, people working with the data part, doing the visualization, sort of doing this combination of all of these things. I'm almost out of time, so I'll talk a little bit about the future of notebooks. So as you said, there's now two specific applications. There's Notebooks 3 and Notebooks Live. We're planning on sort of bringing those together using basically the web version as the standard, and then using something like Electron, which is used by Slack or GitHub Desktop or all of these applications, Spotify for example, to basically run that version on the desktop as well, because we really think it's important that we have something that's open source, that's freely available, that's supported by the community, but also, as we just sort of heard in the previous previous presentation, I think it's important that these things stay resilient, that they stay there over time, so I really believe in the fact that these things will be open source and that you can keep reusing them forever. So that was my thought. Thank you.
Thank you, Frederick. Now, I definitely want a notebooks workshop for database writing.
We definitely need.
Okay.
This was very impressive, and yeah, we just have to make it work.
Yeah. Okay, let's do that.
Thank you very much.
Yeah, you're welcome.
Our next speaker is Joost Hooper. He is. Are you the director of OpenStreetMap Belgium? One of the directors of OpenStreetMap Belgium. So he is managing the OpenStreetMap Belgium community, and he will talk about how they try to integrate official data about streets into the OpenStreetMap platform. And as you'll notice, this was not an easy task. He also has an interest in data visualization, as you can see from the GIF that we are already seeing. So I'm very curious what he has to say about integrating government data into OpenStreetMap. So take it away, Joost.
Is this thing working? Is it? Okay. Hello, I'm Joost. I am a mapper. It's usually how these meetings go. I'm going for the animation for attention grabbing thing that was mentioned before. I like that. At OpenStreetMap, our mission is to map the world. And small disclaimer, we don't really know why. It's more like an addiction than anything else. At least it is in my case. I really like maps. I still have like an atlas at home as well. That hold dearly. OpenStreetMap is all about map data, and it's shown there. And we like to make pretty maps with them. It's not just like about making those pretty maps, it's also about feeding them to awesome apps that allow you to navigate offline wherever you are in the world, and doing nifty things like, let's feed these 10 lines of XML, and now I can do a route that takes intentional detours to take a little path because I like walking the path. That's the kind of thing that's very easy with OpenStreetMap. Now, it's not just about like hackers having fun. This is an OpenStreetMap-based Garmin device, which is basically standard now, and more you see that our data is becoming like the default. This is a list of sponsors of our most recent international event. So there's some rather big names there. Note that it's not just private companies, but also the biggest sponsor of all was actually a government organization. And that is no coincidence as well. There's Apple isn't mentioned because they don't like it. Apart from all the big boys using it, it's also a base for a lot of humanitarian activity. It allows you to, in this case, over 2,000 people were working at the same time to map the whole region where the Ebola crisis was happening, which allows not just for the people on the ground to actually find their way, but even more importantly, to map the people who were sick. So when they would say, I am from this and this village in this and this district, that they would know basically exactly where that is. And that in a region where this kind of data is absolutely impossible to find in another way. our mapping is kind of different from the usual mapping style. For example, at the government, they start with a problem. They say, yeah, we want to know where our roads are. So they start with a definition, this is a road, and we're going to build a system that can contain these roads, and we're going to collect them all. And they do it, and they mostly do it properly. But as you can see, there's like this big hole in the middle, because, yeah, we're Flanders, we don't care about Brussels. So after a while, it usually works, and then they decide, oh, but actually we only included like big roads where cars can drive, and maybe those paths, after all, the paths and trails and tracks, that's also interesting. So let's extend the system, and then you need to do a huge project to do the next level of your project. And then, oh yeah, these paths do change a lot, so we might need to do like an inventory of all those little paths, and then they work together with another organization to do an inventory of all the little paths. So it's a slow evolution where the scope always changes, but in like big chunks. And when you have this, then you say, maybe we can use this dataset for routing, and then it becomes ever more complicated. At OpenStreetMap, it looks more like this. Every color here is a unique mapper. So it's this patchwork of people working on the area they like, on the topic they like, and it looks like a big mess. So we started mapping in Belgium in about 2007, and the network started growing. Now, why I show this one in particular is that you can clearly see like different kinds of roads. You can see it grow and evolve, but you can also see like even from the very start, people were mapping not just like the big roads, but also the local paths and trails and the small suburban roads. So that's really like people mapping what they know, mapping what they find important. So it's a lot of chaos. Now, this chaos actually, yeah, this is Excel, sorry. There is a method to the madness. As you can see, like we started off in 2008, the most common type of road were like the main big roads, like where cars go. But even by 2010, the minor roads were already more numerous. And now, by 2017, you can see that tracks and paths are becoming ever larger. So even though we are all just crazy people doing what they find the most important, there is some structure in there. You can also see that it flattens out. I'll come back to that. Now, as we go mapping more stuff, it's not that we kind of lose interest. There's a lot of people scared of that. So on the right-hand side, you can see the number of kilometers added to the network. And you can see that was, at the beginning, there was like this titanic job. It was really fun, before my days, to add all the new roads. But by 2010, 11, that started to be done. On the left-hand side, you can see the amount of work being done on those same roads. So even though there were no new roads to be added anymore, people were working more and more on those roads because they were adding ever more tiny details. Of course, names, maximum speeds, but now we do like number of lane mapping, different types of boulders that can be in the way, different kinds of barriers. There's a lot of things we find interesting. In comes road completion. So we've been doing all this for a long time. You can see it flattens out. So are we complete? How are we doing? And even as our data set matures, we still see that a lot of people are still like very skeptic to this bunch of volunteers, and I guess I would too if I didn't. Well, even if you knew them. So it's a bit weird what we're doing. One of the main goals of the road completion project is to have a look, another animation, have a look at how complete we are compared to the government road data, because we know they have a certain methodology, and we might not really trust their data, but we know that it's according to a certain definition, and we trust them to do what's in their definition. And here you can see that it starts out very uneven, but by the end you can see that everywhere is at least like 95% complete compared to the government data. If you look at a completeness graph, so this is the same but just like for a few areas, you can see that at the start there is like this big divergence. Some places are a bit slower to get mapped and others a bit faster, but you can see how Flanders, Eastern Flanders and Aalst, it's just an example, how they all converge to the same point. you can also see that by 2013 it doesn't really change very much at all anymore. There's two reasons for that. We're comparing to government road data, and well, this data set we're comparing against, it's wegenregister, it contains a lot of private driveways, and we don't really care about them. We do map them, but until now there was no way to just throw them out of wegenregister. A friend of Virus is fixing that, by the way. So there's a bit of garbage there that we don't really care about. Might be errors in the government data as well, of course errors on our side, but we were convinced that we were missing some bits and pieces. I learned this in practice during my work at the city of Antwerp, where we were maintaining where I was paid to help maintain the government data, and on my free time I was doing the same in OpenStreetMap. So I was looking at both sides and I was seeing, oh, we can learn from each other. Together with the other people at OpenStreetMap Belgium, we thought a lot about how to go about this. So it's not just about the completeness measures, but also constant quality assurance we want to do, so that you can at any time see how well are they doing, and also to fill the gaps in the community. So what we want to be able to say is that, well, we're at least as good as the government data. And not just because we believe we are, but we want to have some proof of that. So the diagram behind that is that we have the open data coming from the government on one side, we have the OpenStreetMap data on the other side, we do some magic comparison, it turns, that comparison is output to the community, they do some mapping, when they do some mapping they generate more open data, which can be used by the government to improve their data. We're still hoping that will happen one day. And there are these false positives where we say, there is something wrong here, we have to go check it out in the field, or while we think probably government data is wrong. We feed that back to the comparison algorithm so that the next mapper would not be tempted to just copy it from the source, which actually might happen. The comparison itself is really simple for now, so we want to take it step by step. And right now it's just like we do some buffering on the OpenStreetMap data and we find government weights that are outside of the buffer. So if there is a road segment from the government that is mostly outside, 5 meters away from an OpenStreetMap road, we consider it missing, and then we create a micro task of that. These micro tasks are then fed to an existing tool where you get this one little line, and this is a typical example. So Flanders has a tendency to fill up empty space right now. Fortunately, in this kind of place, it's within existing agglomeration. That's not always the case. But here you can clearly see that there is this new road with an actual name. This is old imagery, so you can see, okay, this is something new, and we missed it. Why did we miss it? Well, because nobody needs to go there. I mean, how we depend on about 10,000 people reporting or fixing randomly what they happen to visit. Some of these people have a lot of tendency to collect random data because they go hiking every day and they actively look for places like this. But of course, we might still miss these kind of developments, and then the government is actually faster than us, and that's what we want to avoid. This kind of micro task, you can just do it. It's ready for mapping. It's actually kind of addictive, so I don't know if I can recommend it. But, well, give it a shot. It's fun. I can give you a demo. If you're interested in the whole project, I mean, we have a lot to do. This is half theory and half executed. We regularly do OpenStreetMap Belgium meetups. It's a lot of fun. It's less formal than here. I think the amount of beer is similar. Next steps, we want to add all the missing roads. We're in progress. We have some things to do. We have about 10,000 tasks left, 8,000 left to go, but we might filter that down to 4,000. We hope the government will consume our open data. We're building a daily comparison tool, but that's actually quite complicated. And one day we want to expand to more data sets. So right now we do the roads because it's a simple use case, and quite important. But later on we would like to do some buildings as well, and maybe we could go into POIs or, well, whatever. We'll get there somehow. Now the good thing is, like when we're working on this, some of the comparison is rather old and a lot of them are already fixed. So even if we did nothing from OpenStreetMap Belgium, the data would just keep improving. We're really confident about that, but we want to like speed it up a bit. For the building and address import, I'll just say, show one little slide about that. Sorry, it's not animated. So this is the status of the building and address data in Belgium in OpenStreetMap right now. So again, it's a very diverse image. The yellow bits are imported, so that means that someone copied the data from the government. We don't just copy, it's like we copy it and we integrate it with what exists. So for example, if you go to a rural village in the mountains on Google Maps, you might find that the buildings are here, all machine learned, and the roads are here, all drawn by hand, and they didn't conflate it. That's the kind of thing we really don't want. So we have a lot of data. We don't work with layers. Everything is a huge pile of data, but that also forces you to like make a consistent data set. So the yellow you see represents really a lot of work. The red is just people drawing houses, not adding any address information. So these are people who just enjoy drawing houses. The blue is mostly, it's one guy who lives somewhere in Antwerp who likes to draw houses, but also copies the addresses, for which we're really grateful. Most of the yellow you see outside of Brussels is fairly recent. So we've only really started importing buildings for the last 3 or 4 months. It's a very different kind of task. It's also very enjoyable. One of the things I like most is that quite soon we will be able to generate statistics of the number of kiekenkoten, so garden sheds and private garages in the municipality. Like I think from Bruges we already have like 4,000 or 5,000 private garages mapped. So that's the kind of, I mean, shocking statistic. I find it shocking that so much space is dedicated to bloody cars in an urban environment. And it's also an enrichment of the official data, which doesn't care what the building is for. So they just say, here be a building. And while we are working with the data, we enrich it with that kind of stuff. So yeah, so that's us. And this is also us, and we want you to be us. Yeah, take a picture and come to our event. Thank you.
As you might know, I'm a map lover, so I'm also a fan of OpenStreetMap Belgium. They're doing some very nice work, and as you see, big companies are also listening and checking what OpenStreetMap is doing. So yeah, let's keep all an eye on that and think about OpenStreetMap as a source of very diverse and very interesting data to be visualized as well. So we're going to have a little break now, 15 minutes, so we can get started again at 20:30. So this gives everyone an opportunity to let all interesting bits that we have seen to just be consumed in a proper way and discuss the things we've seen, and then we'll get started again at 20:30 for 2 more stuff. So see you in 15 minutes.
Ik ga kijken hoeveel gemeenten, hoeveel ETM's staan er nog in. Dus dat is eigenlijk de kruid gedaan, die op de schip. Die waren dus dat eigenlijk zo maar, je krijgt veel, je krijgt heel veel, je krijgt zoveel dat je denkt, het zou eens kunnen dat. Dus de opname